today. If anybody has any questions, I can take those now. If anybody's got a quick one or two. All right, we're not seeing anything, so I'll start the lecture. Now, we were talking about lists, and so what I've done is I've taken all of the list stuff out of the, well, I haven't taken it out of the previous lecture, but I've made a separate copy of it. And so now there's a separate list lecture. So like half the lecture used to be in the objects lecture, and then it was split over 2 lectures. Now it's all in 1 lecture. Let's see. Okay. So just to quickly remind you what's going on, Java has this. Java has a type called list, and it has a implementation called ArrayList that provides you with the functionality of the abstract data type called list that you would have learned about in your data structures course. Java also has a linked list for you to use if you want to, but you almost always use ArrayList because ArrayList is almost always the faster list. The list type in Java is what's called a generic type. So you have to specify the type element that you want to place in the list. And the way you do that is with this this diamond, is what's called the diamond operator. It's easier to show you an example, right? So if I want to make a list of string, right, then the full type name is ArrayList less than string greater than. Call the constructor, it's ArrayList, and then less than, and then the same type that's on the left-hand side. After Java 7, you can ignore or you can leave out the type from inside the diamond on the right-hand side. So the compiler will infer the type from the left-hand side and insert it for you automatically, so you don't have to retype it in. Now, you'll find that if you actually type in just plain old ArrayList, it'll actually work. And that's because of the way that the generic types were introduced into the Java language. So it will work. The compiler Eclipse will warn you that there's an error. So you'll see a yellow or an orange underline in your Eclipse window. Actually, I can show you that. I'll show you that when we do the demo at the end. So you can leave it. You can technically leave it out, but you should include it, right? So you should include the empty diamond, and you really should include the diamond with the type on the left-hand side when you declare the variable. Oh, I still didn't fix that. All right. So just to quickly remind you, one of the big limitations of Java's generic type mechanism is that you cannot make a generic collection of primitive type. So I can't make an array list of int, for example. I have to use one of the corresponding wrapper classes instead. Every primitive type has a corresponding wrapper class, right? Little b boolean, its wrapper class is big B boolean. The names almost match up except for car, right? So the wrapper class for car is character, and the wrapper type for int is integer. So the wrapper classes are needed because the generic types can only store references. So that's why you can't have a list of int, right, for example. Right. Now, the way the wrapper classes work is that the compiler treats them specially compared to most other classes. So in particular, the compiler will try to convert between a wrapper object and its corresponding primitive value. Right. So here's an example where I have an int, right, I can store the int in a variable of type big I integer. Right? So Java will silently convert the int value to an integer to an object that represents the same value, and then you can store a reference to that. Similarly, you can go the other way. Right? So if I have an int variable k, I can assign the integer value j to k, and so the compiler will silently extract the int value from the integer object here and store that in k. Right? So when you go from the primitive type, when the compiler goes from the primitive type to the wrapper class, that's called auto boxing or boxing. When the compiler goes from the wrapper type to the primitive type, that's called auto unboxing or just unboxing. Right, so if I want a list of int, you have to make an array list of integer. Right, if I want a list of double, it's an array list of big D double. And if I want a list of character, it's an array list of big C character. Okay. All right, so this is where we left off at the end of last class. Okay, so to make an empty list, you use a constructor. Right, so when you use a no argument constructor, right, no arguments here, that always makes an empty list. Right, so you've got a list T, it has no elements in it. Right, if you try to get something out of this list, or if you try to set a value in the list, that will cause an error because the list is empty. Right, there's nothing in it. So you have to add some stuff to the list before you can get a value back out of the list. Right. So the way you add something to a list or append a value to a list is with the method called add. Right. So t.add some value will add that value to the end of the list called t. Right. So add is really append, right? Append to the end. Now this is an int value. Right? But it's a list of integer value. So the compiler auto boxes the 100, right? The primitive 100 into an integer object, and then adds that object to the end of the list, or adds a reference to that object to the end of the list. Now, once you've added something to the list, now you can go and get something from the list, right? So in other words, I can go into the list and get the first element. So the method to get an element from the list is called get. And that gets by an integer index, right? So this gets the element at index 0, right? Now in this piece of code here, I'm going to store the result into a primitive variable called first. Right? List stores references to objects, right? So in other words, there's an integer. The result of get here is a reference to a big I integer object. So the compiler auto unboxes the integer and stores it. The integer object gets the int value and stores the int value into first. Right, so you can see that there actually is a lot of stuff going on under the hood when you use the list. When you use a list in Java with primitive types. Right, there's conversion back and forth from the primitive value to the wrapped value every time you use it. Right. Now you might be worried that that's computationally expensive. It turns out it's not very expensive. So it's unfortunate that it works this way. It works this way because the generic facility was added to the Java language fairly late in its lifetime. Right. So there had been it was version 5 of the language when the generic facility was added. So there was no other way at the time to introduce generic types into Java and not break all the existing code, except to create this the wrapper classes. And so that's just the way life goes. All right, now the auto boxing and unboxing almost always works, so you almost never have to worry about it. There is one specific instance where you do have to worry about it, right? So there's a method called remove in the list that lists have, right? So remove will remove an element, but you have to be careful when you use the method with a list of integer, right? Here I've got an array list of integer. Right, I'm going to put some elements in, right? That's what that comment means. So I'm going to call add or some other method to put a bunch of elements into the list. And I would like to remove the first instance of the value 100 from the list. Right, so I want to remove the first 100. So you might naively write t remove and then the int value 100. That's what you might write. Unfortunately, this doesn't work. Right? So that's why there's a question mark here. What that actually does is it removes the element at index 100. So it turns out there is a version, there's two versions of remove in the list class, right? Version number 1 takes in an int, right, which is this example here, right? So it takes in an int argument. It has an int parameter. That version of the method removes by index. Right? So in other words, it interprets that int as an index and removes the element at that index in the list. Right? If you want to remove a value from the list, right, then because this is a list of integer, right, you need to pass in an integer object here, right? So to remove the first integer object whose value is 100, I need to make an integer object whose value is actually 100, right? And so here you can't rely on auto boxing to work, right? Because the compiler doesn't auto box here, right? Here the compiler sees, oh, there's a method that takes in an int, so I'm just going to call that method. You really want to remove an integer, then you have to pass in an integer object, right? So the way you create an integer object with a certain, with a particular value is to use the static method value of. Integer dot value of 100. You can also call a constructor. So you could write new integer round bracket 100 here as well. And that would also work. Okay, so this is the one place you have to pay careful attention. This is the one place where auto boxing and unboxing does not save you. Okay, so what can you do with a list? You can do a lot of things with a list. Right. Now, I'm not sure. So I have no idea what you learn in your data structures course. So I don't know how many functions you implemented for your list type, if you implemented any at all. Right. I assume you can. I assume you learned how to set an element or replace an element in a list, how to add an element in the list, and how to get an element from the list. Probably how to remove an element from the list. But there are other things you can do with lists. And so the Java list type gives you a very rich set of features. Gives you lots of methods that you can use. All right, so if you want to make an empty list, you call the no argument constructor. Here's an example. Right, so I'm going to make a list of string. Right, I'm going to call the list t, or I'm going to call the variable t. Right, and I just call the array list constructor. No argument constructor, so that gives me a list of size 0, right? An empty list. Is a list empty, right? So one way is to get the size of the list and then check if that value is 0. But it turns out asking is a list empty is very common. So there's a method for it. Right? So the method is empty, right? No arguments, right? That'll return true. If the size of the list is 0, it'll return false otherwise. If you want to know how many elements are in the list, the method is called size, right, which is a little annoying because the corresponding method in array, the corresponding field in arrays is length. Right. Similarly, if you want the size of a string, it's also length. Right. The method's also called length. For lists, it's size. Appending to the end of the list I showed you, that's add. So I can add to my list of strings, right, by passing in a string. So I can pass in the string hello. Everything works fine. If you want to get an element by its index, right, so it's 0-base index, right, so like using the square brackets with an array, the method's called get. T get 0, that gets the first string that's in the list T, right, returns a reference to that string. So I can store that in the variable E. Set, you have to worry about. Get and set are probably, well, set for sure is badly named. Set replaces an element by index. Right? So what that means is there actually has to be something at this index for set to work. Right? So for example, if you have an empty list and you write t set 0, you'll get an exception. Right? So when you run your program will crash, and it'll say there is no element at index 0. Right? So set actually replaces an element, so the element has to be there to begin with. Because we've already added an element to the list, I can then change the element that's in the list. Right? So I can set or replace the element at index 0 with a new string. Now the element at index 0 is the string goodbye. Does an array list implement? No, that's the problem. So as I mentioned in a previous lecture, the square brackets are actually an operator in Java, and Java doesn't let you redefine operators for types. So unfortunately, the square brackets don't work, right? So the get and set, that's the analog of using the square brackets, right? So get is the analog of using the square brackets on the right-hand side of the equal sign. Set is the analog of using the square brackets on the left-hand side. Right, so this would be the same as t square bracket 0 square bracket equals goodbye, right? If you were using an array. So there's no operator overloading in Java. All right. If you have a second list, then you can add all of the elements that are in the second list to another list. Right? So if I have another list somewhere, right, then I can add all the elements from that list to the list T. So they all get added at the end of T, right, in the same order that they appear in the other list. Right, so if another list has the strings A, B, C, right, then after I call add all on T, T will be the list goodbye, then A, then B, then C. The list class has two remove methods. One of them takes in an integer value, an int. Right? So remove by index, right? Removing the element, you pass in the index of the element that you want to remove, right? And that will remove that element. Now, after you remove the element, right, there's not a blank spot in the list, right? There's not some empty spot. What happens is everything after the removed element, that gets moved forward one position in the list, right? So there's no blank spot in the list. Everything that's after it gets shuffled forward one position. Right? If you want to remove an element that's equal to that, right, then there's a second version of remove, right? So if I wanted to remove the string goodbye, I can write t.remove and then in double quotes goodbye. Right, and that will remove the string goodbye if it's in the list. If it's not in the list, I don't remember what happened. I think you get false for the answer. The way to find out is to always look at the documentation. So remove, yeah, remove returns a Boolean. So rows, okay. So it removes the first occurrence of the specified element in the list if it's present. If it does not contain the element, the list is unchanged and it returns false. Right. So if it removes the element, it returns true. If there is no element equal to that, it returns false. Right, and does not modify the list. To get a sublist, so Java's list class is kind of cool in that you can get part of a list. So if I want to get, say, the back half of the list, then it's possible to do. And furthermore, if you change the returned list, that also changes the original list, right? Which is kind of neat. So if I get the back half of the list and I make some modifications to the back half of the list, then that also changes the original list. So the method here is called sublist. Where did my cursor get to? Hang on, something funny's going on. Well, that's not good. Sorry, I seem to have lost my mouse. So just give me a second here while I try to get it back. Oh, wait, there it is. Is it working? I think my wireless mouse battery has died, is what's going on. All right, so everybody hold on 2 minutes while I run downstairs and get another battery. Sorry about that. Okay, I'm back. All right, so the sublist method will give you back part of a list. Now, the way the sublist method works is you pass in the starting index of the part of the list that you want. Okay, so if I want the, so suppose I want the sublist, so I want everything after the first element of the list, then I would pass in 1, okay, for the starting index. Now, the stopping index is a bit odd. So in the sublist method. Okay, so the sublist method says it returns a view of the portion of this list between the specified starting index, so that's your starting index. Now notice it says inclusive, and the ending index exclusive. Okay, so to index, right? So that part there, that's your end index, but the return sublist does not include the element that's at the end index. Okay, so in other words, the returned sublist does not include the element at that index, right? So it stops, the last index in the sublist is at index stop -1. Okay? So if you want everything in the list starting from the second element to the end, you would pass in 1 for the start and t dot size for the stop index, right? Because the size of the list is 1 past is the index that's 1 past the end of the list. So that's a bit weird. And then if you want to make a new copy of a list, so to copy a list, it's easy in Java. You just make a new list and you pass in the list that you want to copy. Nice and simple. So just use a constructor and pass in the collection that you want to copy. Now, what's not here? So there's some things that you occasionally want to do, right? So occasionally you want to reverse a list, or you want to shuffle a list, or something like that, right? So you want to randomly shuffle the elements in the list, or something like that, or you want to count how many times something appears in the list. Okay. So those methods don't appear in the list class itself. Right? Those methods don't appear in list itself. Right? Instead, there are a bunch of methods in this class here. Right? So there's a class called Big C Collections that's in the package java.util. And this class contains a whole bunch of methods that operate on lists and another type of collection in Java called set. Okay? So I'll click on that in a second. One example of a method that's in the collections class is this thing called frequency. Now, collections is what's called a utility class in Java. So a utility class is a class where all the features are static. So they're public and they're static. Right? And what that means is to use any method in collections, you always use the name collections dot. So the class collections with an S, right? It turns out that's the utility class that operates on something called a collection in Java, right? Big C collection. So we'll talk about more about this later on in the course, right? But it turns out in Java, lists are actually they are actually instances of this type called collection. When you see a class that's pluralized in Java, so collections with an S, then that usually means it's a utility class that operates on objects of type collection in this case, right? So there's a class called arrays, right? That's a utility class that operates on array objects. And there's a few of these utility classes in the language. So to count the number of times the string ABC appears in the list T, you can use the frequency method. Want to reverse a list, then it's just collections.reverse T, the name of the list. You can randomly shuffle the elements in a list. So there's a method called shuffle. Right? So it's collections.shuffle and then the name of the list. If you want to sort a list, then there's a method called sort, and you pass in a list that you want to sort. I forget which version of the language added it. It's either 8 or 9. 8 or 9 added a sort method to the list class itself. So the other way to do to sort a list is to call the sort method that belongs to the list. So it's t.sort, and then you pass in this value null here. So null means something similar to what null means in C, right? So you know that in C, the null pointer points to no object, right? In Java, the null reference refers to no object, right? So it turns out the sort method, you can actually pass in an object that knows how to compare elements, right? If you pass in null, right? So in other words, you say, well, I have no object that can compare elements. Then the sort method will use the default sorting, will use the default comparison method for the element type that's in the list. Right. So what that means is if you have a list of string, you sort the string by passing in null. Then sort will compare strings using the strings method using the string classes compare to method. Right. So in other words, it'll sort the list of strings by using the dictionary order of the strings. Right. You can change the way that it sorts by passing in a different object here. If you just want to sort the list and you don't care how it sorts, like you don't care, you just want to use the compare to method that belongs to the element type, you can just use collections.sort. Oh, I guess we should see what else is in this class quickly. So the description of the class says it's a class that consists exclusively of static methods that operate or return collections. So in other words, it's a utility class for collections. And if you scroll through, so the reading the methods are going to be it will be a little bit difficult for most students at this point because it's using a syntax that's unfamiliar to you. Right? This is a little bit weird. We'll learn more about this towards the end of the course. Right, so when you see stuff like this, you can just sort of ignore it for the time being. There's this method called add all. Right, it will take in a reference to a collection. That will add all of the specified elements to the collection T. Sorry, that will. Sorry, let me try that again. Add all. You can pass in a comma separated list of elements. And it will add those elements to whatever collection that is. Right? So if you pass in a list for the collection here, and then you pass in a bunch of elements, it'll add all those elements to the list that's there. Right? You can binary search a list. Right? So if you are familiar with the binary search method, then there's already a binary search implementation for you. Right? So this will binary search the list for the value called key. Right? And if you keep on going, there's a whole bunch of other methods here, right? A lot of these, we won't have any use for them in this course, right? But they are useful for other people. You can copy a list, for example, here, right? So you can copy a list. You can copy that list into that list there. Right? So it'll copy the elements from the source list into a destination list. Right? Keep on going. There's the frequency method. The fill method will fill a list or replaces all the elements of a list with that value there. Right? Max, so you can find the largest element in the list. There's a min, right? Find the minimum element in the list. There's reverse, so you can reverse the elements in the list. There's shuffle, so you can randomly shuffle the elements in the list. Where's sort? There's sort. Right? So you can sort the elements of the list. Now, if you want to sort the list in a special way, so if you want to suppose you wanted to sort a list of strings using the length of the string. So I want the shortest strings at the front. I want the longest strings at the back. Right? Then there's a second version of sort. Pass in the list, and you pass in a special object that knows how to compare two strings by their length. Right. So later on in the course, we'll learn how to implement. We'll learn how to use this method here. Right. So we'll create a class that knows how to compare strings by their length, and we'll and then we'll use this version of the sort method. Right. So there's lots of methods here for you to look at. Where? Oh, sorry. Do I have? Oh, it's here. Okay. Right. So if there's something you need to do with the list and it's not, you can't find it in the list class itself, the next place you should look is probably the collections class because it may already be there. All right, so what else can you do with a list? Well, a list is a sequence of elements. Okay? So it's sort of like an array, except you can change the size of a list, right? And you can, yeah, you can change the size. And you don't have to do anything special, right? So if you add something to a list, and there's not enough storage in the list automatically grows its storage for you, right? So the programmer doesn't have to worry about that. So if you want to loop over the elements in the list, you can use a for each loop, right? So I want to find the shortest string in a list T. Right? I also have to, for the purposes of this example, I have to assume that the list is not empty, right? So it's not empty. So I want to find the shortest string in the list, right? So I start by getting the first element in the list, right? And then I get the length of that element, right? That's the shortest string that I've seen so far in the list, right? I've looked at the first element in the list and I've gotten its length. That's the shortest element. That's the shortest string I've seen so far. And now I just look at all the other elements in the list, right? One way to do that is to use a for each loop. Right? So for each string S in T, right? Remember that's how the for each loop works, right? So for each string S in T, right? Length of S, right? So if the length of that element is less than the min length, right? Then I found a shorter string. So I set min length to S dot length, right? And now my shortest string is equal to S, right? So that will return the shortest string in a list. Now, you don't have to use the for each loop here, right? I can use a regular for loop. The one very small disadvantage of using the for each loop here is that you look at the first element twice, right? Because that's the way the for each loop always looks at every element. Here, I've already looked at the length of the first element, right? So there's a very small disadvantage to using the for each loop. Want to? You can use a regular for loop. You can always use a regular for loop in Java. Right? So if you don't want to use a for each loop, you never have to use it. To use a regular loop, I can start counting at 1. Right? I can start looking at the elements at index 1 instead of at index 0 because I've already looked at the element at index 0. Right? So starting at index 1, as long as the index is less than the size of the list, right? I can then get element from the list, right? So I get the element at index I, store that in the variable S, and then the rest of the code is the same. Right, so that's how you iterate over the elements. That's one way to do it. There is another way to do it. So if you're reading when you read the list notebook, the list notebook will tell you that there's this thing called an iterator. So you can make an iterator object, and the job of an iterator is to iterate over the elements of the list. Right? So there's a third way to write a loop where you use an iterator object to loop over the elements. Right? I'm not going to do that in this particular lecture, but it is in the notebooks for you. Now, finding the shortest string in a list is something you might want to do more than once. So you can always write your own method that can do this. Right? So let's make a public static method that finds the shortest element in an array list called T. Right? And it returns the string, the shortest string in the list. Right? Now, if the list is empty, there is no shortest string. So here you've got a few choices, right? One choice is to return null, right? So if the list is empty, you can simply return null to indicate that there is no shortest object in the list, right? There's no shortest string in the list. So that is a valid design decision, right? The problem with returning null is that programmers tend not to check the return values, right? It's not just in Java. This is true in every programming language, right? So programmers tend not to test the value of a returned, tend not to test the value of a return value before they use the return value. So if you return null here, and the programmer tries to use the returned value, right, then they'll get what's called a null pointer exception, right? So they're expecting back a string. They're going to call some method belonging to the string, right? So they might, for example, get the length of the returned string, right? Now the problem is if you try to call length with a null reference, you end up with what's called a null pointer exception, right? Because you can't call a method if you don't have an object. Null means no object, so you can't call a method with it, right? So normally what happens in Java is instead you test, right? Is the argument that was passed in, can I actually find the shortest element in that list? If the list is empty, well, there is no shortest element. So in this case, I'm going to throw an exception to indicate that the caller has called the method with an invalid list. Right. So the way you do that is you write throw new illegal argument exception. So there's lots of exception objects you can choose from. This is the one that we're going to use the most in the course. Right. This is the exception that you throw. This is the exception that you typically throw when you validate an input argument. Right. So if the list is invalid, throw an exception. Right. If you want to, you can include a little string here that indicates something about the cause of the error. Right, so the cause of the error here is that you passed in an empty list. So you could write something like, right, and then when the caller gets the exception and their program crashes, they'll see this message. Right. Okay, would we create a method for finding the shortest string if we have to repeat this method many times? Yeah, so with different strings, you mean with different lists, right? So you would create, if you find yourself having to find the shortest string in a list more than once, then yes, you should absolutely create. You never want to repeat code unless you have a good reason to do so. Right. So if you need to find the shortest string in a list more than once, you should definitely make a method for it. Right. And now the rest of the code stays the same. Right. Now, what happens if I didn't check if the list is empty here? Right, so imagine this test validates the input argument's not here, right? So if you assume the list is not empty, and you write t.get0, right? If the list is not empty, everything's fine. But if the list is empty, right, you cannot get the first element from an empty list. So get is now going to throw an exception. So get will throw an index out of bounds exception, right? So your method's going to crash anyway, right? It's better to tell the caller that it crashes because it's an empty list, right? Rather than the caller getting back index out of bounds exception, right? Because it's a lot easier to interpret that message than it is to interpret the index out of bounds message. Because the caller is going to wonder, why is the index out of bounds when I'm trying to find the shortest string in the list? So you can only safely call get if that list is not empty, right? Which is why you should have the test here. Right, otherwise the rest of the method is the same as what I just showed you in the previous slides. Okay, let's look at a little example of using a list. Right. So I want to write a little simulation that computes the odds for rolling a certain value with a pair of dice, right? Now, I'm sure most of you know how to do this, or have, at least you know the answer, right? So I'm sure most of you know that if you roll two dice, two six-sided dice, then the most common value is 7, right? The most likely value is 7. The least likely values are 2 and 12, right? And I'm pretty confident that a lot of you could know how to compute the odds because you've taken some sort of counting course, right? Some sort of either probability or some course where you learned something about finite math, right? How to count things. Now, if you don't know that, right? If you don't know how to do, if you don't know how to compute the actual odds, you can always write a little program to do this, right? So to write a program to do this, you just simulate rolling two dice a whole bunch of times, right? So say you simulate rolling two dice, say 1,000 times, right? You just count the number of times 2 appears, right? You count the number of times 3 appears, you count the number of times 4, and so on and so on and so on, right? And then you divide by 1,000, and that gives you your probability, right? Or that gives you an approximation of the probability. Now, how do you make random numbers in Java? So there's a class called random that lets the programmer generate random values. Right? The class random, right, can generate almost any primitive random values for almost any primitive type. Right? So you can generate a random Boolean, so true, false. Right? You can long, a float, or a double. Right? If you're interested in how this thing works, click on that link there. If you want to see the documentation for the class, click on that link there. Right? I'm just going to use the class and show you how to use it. So how do we do this? Here's my little algorithm. Right? Remember, I want to make this table here, right? Basically, I want to make this table, right? So I want 12 minus 2 is 10. So there's 11 different values here, right? So I want a list of at least size 11. I'm going to do something weird and make a list of size 13, right? So why am I going to make a list of size 13? Because when I use the index 2, I want that to be the sum of 2 dice values, right? When I use the index 3, I want that to be the probability of rolling a 3, right? And when I use the index 12, I want that to be the probability of rolling a 12. Right? 0 and 1, obviously the probability will be 0, right? You can't roll a 0 or a 1 with 2 dice. I'm going to make a list and add 13 zeros to the list. I'm going to write a loop that runs n times, right? I'm going to roll 2 dice, get their value, and then add 1 to the value at index x in the list. This is easy to do. We can do this in like 2 minutes. I made a class called DiceSim. I've got a main method, right? I want to make a list, right? So create a list and add 13 zeros to the list. Okay, no problem. So array list. Now it's going to be an array list of integer. Sorry, not an array list of integer. Well, we can do integer. Let's do double, right? So these are my indexes. These are the values that I want to store. Right? The values that I want to store, those are real numbers. So I need to use float or double for the array, for the element type. Where's Eclipse? Go. Right. So I'm going to make an array list of double. Let's call it T equals new array list. Right. Now, notice that when you use it, when you write that, Eclipse underlines array list in red, and over here you've got a little light bulb with a red X in it. Right. Whenever you see something in red, Eclipse is telling you there's a problem. So hover over the error, right, and it says, you probably can't read this, but it says array list cannot be resolved to a type. Right, and so this is Eclipse's way of telling you it does not know what an array list is. Eclipse offers some suggestions on how you can fix this. Right? It says, suggestion number 1, import array list. You say, okay, that sounds good. You click that, and there you go. So it automatically imports it for you. All right, so that's the problem. Array list is in the package java.util. So you have to import the class in order to use it. If there's a class in java.lang, you don't import it, right? So anything in java.lang automatically is available to you to use, right? In other words, you don't import anything from java.lang. So for example, you don't import string, right? Or you don't import string. What else is in lang? You don't import integer or big D double or things like that, right? They're automatically available. I want to add 13 zeros to the list, right? So there's a couple of ways you can do this. I'm just going to use a loop. Right now, someone might complain, hey, you shouldn't use the number 13 because it's a magic number, right? And the answer is, yeah, that's probably true. But for the purposes of a program that's this small, right, where it has a well-known, where the problem description is well-known, using the number 13 is not the end of the world here, right? Add 0, right? So I'm going to add 0 13 times to the list. Then I want to repeat the following n times. Okay, so I need a loop. Right, so here it's useful to create a variable n, a constant n, because you might want to, we may want to change how many times we run the simulation. Right, so equals, I'm going to start with 1,000. Right, I'm going to write a loop that runs that many times. Now, what do I want to do? I want to simulate rolling 2 dice and sum their values to get x. Okay, so I want to use the class random to generate random values. Now, I don't want to make the random number generator inside the loop, right? The reason I don't want to do that is because I'm going to end up making 1,000 random number generators, which is a waste. Right? I only need one random number generator, so I'm going to make it here. Random RNG equals new random, like that. Right? Again, Eclipse complains. Right? It doesn't know what random is. Hover over the error. Click import. There we go. Time is it? Oh, okay, I have to hurry up a bit. Okay, I want to 2 dice, right? So the values of 2 dice. So int x, this is dice number 1, right? RNG has a method called nextInt, right? It's got 2 of them actually, right? Notice that if you hover over or click on nextInt, you get the documentation for the method right here, right? I want this version. So I want the version where I specify the upper bound, right? So nextInt right? That will return a number between 0 and 5. So that's how nextInt works, right? So between 0 and 5. I want between 1 and 6, so I just add 1. It was easy, right? I have 2 dice, so I need another die. With y. I need their sum. Right. So that'll be a number between 2 and 12. Right? I now want to add 1 to element at that value. Right? I want to add 1, so I want to get the value. Oops. Right. So if I roll a 5, right, I want to look up in my list how many times I rolled 5. Right, that's what that does. Right, and then I want to add 1 to that because I just rolled another 5. Right, and then I want to change that value, so that's what tSetSum does. Okay. And that's it. You're done. I guess at the end we can divide everything by 1,000. Right. So why don't we just print out the list and then we'll end the lecture and let's see what we get. Run that, and you get the following. Right. So we rolled 0 0 times. We rolled 1 1,000 times. We rolled 2 25 times. 7 is that many times, which you can see is the largest value. Right. So to fix this up, Well, I'll complete this in the next lecture. We're already at 20 after. All right. So in the next lecture, I'll finish. I'll actually complete this method. So I divide by 1,000. We'll see what happens when we change the value of n, and then we'll do another list example that simulates something else. All right. So that's all I have for you today. Anybody have any questions before we end the lecture? All right, I'm not seeing anybody.
Yeah, I just needed that help with
Yeah,
clips.
I remember. Yeah.
Okay, sounds good.
Okay, so I'm gonna help out Noah with the problem here. We'll stop the lecture there.